In this video, we'll be looking at a new unit. So we'll be looking at 6.1. Simplifying square roots. And our essential question will be, how do I simplify a square root? So first, what is a square root? A square root is the inverse of the square. And the square is that exponent is 2. So for example, if I know that 4 to the second power is 4 times 4, I know that equals 16. But what's the inverse of this exponent of 2? Well, the inverse would be saying the inverse is the square root of 16 equals 4. So it's the thing that lets us go backwards. So over here in our column on the far left, I'm going to put a bunch of different common square roots that we need to be aware of. We'll start with 0. Square root of 0, what times itself equals 0? Well, 0 times 0 equals 0. Square root of 1, what times itself equals 1? Well, 1 times 1 equals 1. Okay, then there's no square root of 2, there's no perfect square root of 3, so we'll say square root of 4. What number times itself equals 4? 2. Let's label these. These are perfect squares, perfect square roots. Then we'll do the next perfect square root is 9. What times itself equals 9? 3. Now we're cruising. Notice how on my right-hand side, I'm going to be counting up by 1 every time. Because that's the only way I can get a perfect square is if I come out with a whole number. So we'll have a whole number as our answer over here, but this number is going to change quite a bit. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. 7 times 7 is 49. Square root of 64 is 8. 8 times 8 is 64. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. I think we'll go to, let's see, I think we can do 2 more. Square root of 169 is 13, and the square root of 196 is 14. So that's the first 15 perfect squares. I'm saying 15 because we started with 0. So there's 15 of the first perfect square roots. Okay, so what if we're not given a perfect square root? Perfect square roots are nice and perfect, so they're easy to simplify. So how do I simplify when it is not a perfect square root? So let's look at the square root of 18. This will be our steps. This is our example. And our example is going to be the square root of 18. The first thing we want to do, step 1, is build a factor tree. So how that works is I'm going to take 18, I write 18, and I start kind of breaking down the numbers that multiply to equal 18. So we could start with, say, 3 and 6. 3 times 6 is 18. I'm going to keep breaking down each number below it until I can't break them down anymore, the same possible way. 3 is only 1 and 3, so there's no value in that because it stays the same. But 6 can be broken down into 3 and 2. And we don't want to break down into 1 times 3 or 1 times 2. This is where we would stop. So my factors are 3 times 3 times 2, which equals 18. 3 times 3 is 9. 9 times 2 is 18. So we built a factor tree. So now, this is where it gets interesting. Step 2. If there is a pair of numbers, one of those numbers comes outside the symbol. Numbers without pairs go inside the symbol. Okay, so we need to make sure we have this completely written down. We read it a couple of times so we really understand it. If there is a pair of numbers, one of those numbers comes outside the symbol. Numbers without pairs go inside the symbol. And I'm talking about the square root symbol. Okay, so here's what I'm going to do. I'm going to go ahead and write my square root symbol. And we just have to decide what goes inside and what goes outside. If there's a pair of numbers, one of those numbers comes outside the symbol. Do we have a pair of numbers in our factor tree? We have 3, 3, 2. Well, we have a pair of 3s, so I'm going to circle that pair. That's a pair of 3s, so I'm going to write that number on the outside. Okay, are there any other pairs? We dealt with that pair, and all we have left is a 2, so there's no other pairs. Numbers without a pair go inside the symbol. So now my 2 does not have a pair, so it's going to go inside the symbol, like so. Step 3, which we don't have on this problem. Multiply numbers on the inside together and multiply numbers on the outside together. So if we had multiple numbers floating out here out front, we would multiply those numbers together, and if we had multiple numbers that we put back inside, we'd multiply those numbers together. So let's do another example following these steps. Let's do some extra examples. So let's look at the square root of 50. So first thing we're going to do is build our factor tree. So I have 50, and 50 can divide by 5. So we could say 5 and 10. 5 times 10 is 50. And then 10 breaks down into 5 times 2. Now none of these can break down, so I'm ready to start popping numbers out and putting numbers back in. So I have a pair of 5s, so I'll circle those. I'm going to write my square root symbol. When I have a pair, it comes outside. Anything left behind by itself goes inside. There's only one number on the outside, so nothing to multiply out here. Only one number on the inside, so nothing to multiply there. And that's our final answer. Okay, let's do another one. Square root of 72. Now, a lot of times with these numbers, when I'm building my factor tree, it's not always easy to know exactly what these numbers are divisible by. So we can just use little tricks. Like, well, it's an even number, so I know I can divide by 2. And then we can just use our calculator and say 72 divided by 2, and we get 36. 36 might be a little bit more familiar. I know that's 6 times 6. And we'll break down 6 and 6 into 3 times 2, and 6 and 6 into, we got 2 times 3, and 3 times 2. Now let's find our, okay, now we can't break down this 2, we can't bring down that 2, that 3, or that 2. None of these can be broken down. And I have to look at the end of all my lines, so we can't lose this 2 up here. We got to keep track of that. So I see that I have a pair of 2's here. So this is my empty square root symbol. I got a pair of 2's, I'm going to put a 2 out front. Then I got a pair of 3's, so I'll put a 3 out front. We're going to multiply those together. That's what happens. When I pop numbers out front, because I have a pair, I multiply them together. So I had a pair of 2's, a 2 went out front, a pair of 3's, 3 goes out front, that'll be 6. So I'm going to multiply them together. Now any number that's all by itself, that little 2 goes on the inside. It's the only number by itself, so it stays like that. And then we have our final answer. Okay, let's try another one. Square root of 54. So the first thing we need to do is build our factor tree. What are some numbers that 54 multiplied equal 54? Well, there's 9 times 6. Now these can be broken down. We have 3 times 3, and then 6 is 3 times 2. None of these can be broken down any further, so we're ready. So I'm going to write my square root symbol and decide what's going on the outside, what's going on the inside. Looking for pairs. Oh, got a pair of 3's right there. So I'll put a 3 on the outside. And then there's no more pairs, so I only got these single guys. So I got a 3, and we're multiplying and a 2, like so. So our answer will be 3 on the outside with our square root of, and then we multiply those numbers on the inside, and we have 6, and that's our final answer. Like so. Let's do one more example. Ratchet up the difficulty a little bit. We're going to do the square roots of 108. So we'll build our factor tree. Again, sometimes we don't know all these numbers that multiply, so a good fail-safe is to say, well, it's an even number, and all even numbers are divisible by 2. So I'm going to start with 2. If you know a better route, take that better route. But sometimes we just got to throw something at it. So I'll use my calculator. 108 divided by 2 equals 54. So we get 54. 54, another even number, so I can divide it by 2, and we get 27. 27 I'm starting to get a little bit more comfortable with, so I can say that is 3 times 9, and then 9 breaks down into 3 and 3. And now we are able to find our pairs and go from there. So I have a pair of 2s. So I'm going to write my square root symbol and start putting things outside and things inside. Pair of 2s, so I got a 2 outside. There's a pair of 3s, so I got another 3 outside. And then I have a singular 3 by itself, so that one goes inside. Pairs pop out. Singles go in. Now we clean it up by multiplying numbers on the outside together and multiplying numbers on the inside together. And we're done. I do want to make a note that sometimes you just can't take square roots of numbers. For example, if you were this is like a special case. Say we're looking at the square root of 19. If I go to my factor tree and I'm looking at numbers that multiply together to equal 19, well, the only way is 1 and 19, so I'd be left with the square root of 1 times 19, which is the square root of 19. So sometimes it's just going to stay the same. And then you just write, oh, well, this one can't factor down. There's no numbers that multiply to equal 19, so I'm just going to leave it the square root of 19. So occasionally that does happen, so be aware of that. But all in all, this is how you take square roots. And thank you for watching this video, and I hope you have a great rest of your day.